tan is secant squared. Keep the inner function inside.
Yeah.
And then you got to take the derivative of the inner function and multiply it onto the result. I just put it in front for so it would not confuse you.
Okay.
Later on, it looks better. All right. So dy dx now, all of its symbols, negative e to the x secant squared of e to the x is inside that secant function. Just hang on. And then on the bottom, the absolute value of tan e to the x. Looks like a spelling contest gone horribly wrong. So doesn't it?
You got it.
Sorry, there's hardly a number up there, right? You know what I'm saying? Right.
This is so unnecessary.
What's that?
I feel like this is so unnecessary.
This function, it is. I'm telling you, it's just practice. You're never gonna see this thing ever. This thing doesn't model anything in the world that we're aware of, right?
Then why do we use it?
It's just practice. It's practice for chain rule. It's practice for knowing this derivative. Make sure you remember this derivative, and make sure you know how to go through a chain rule. It's just practice.
That's so annoying.
Right? That's all it is. That's the way to view it. It's like,
It doesn't compare to anything.
it does. Look, when you play, who plays an instrument? I knew you did, Carrie, I could tell. It's just like Shakespeare and all that. Fartsy stuff. So, I'm just kidding. So, what instrument do you play? Flute, piccolo? Those are two different things, right? Okay, fine. Not the piccolo flute. So, are you pretty good? Assess yourself honestly. You're pretty good? Okay, you are. Fine. We believe it. So, what did you start out playing, though? What did you start out playing? What was like the first song you learned?
Probably
Hot Cross Buns. Hot Cross Buns. Does anybody want to hear Hot Cross Buns?
Sure.
No,
You're never going to go to a symphony and hear Hot Cross Buns. I guarantee it. You never. Never. But I bet you practiced Hot Cross Buns a lot of times.
No.
She did. This is Hot Cross Buns. Right? That's all it is. You're practicing something that has no real relevance to anything, just to get down the notes and the intonations you need to make and the particular shape of the mouth you need to make to get through something much more complicated or something much more relevant, perhaps. Right? That's all it is. Everything's like that, isn't it?
No.
What's that?
I faked my way through those years.
All right, fine.
Make it till you make it. Make it till you make it.
We can't tell at all, Justin.
Nope.
I can't.
So you
I'm not
think like
joking.
you were playing?
Yep.
Like you were playing?
Nope.
You were lip syncing the whole time.
I played the trumpet. I figured the
You
notes.
just made notes, and the
that's
other
not
trumpeters took over. They just took care of that. I hear.
The rest of it was super important for you.
I used to be in the.
Oh, it was still high school.
But you still passed band, right?
Oh yeah.
Yeah. Okay. Good.
Oh, I
Can't
thought
fail
you put it
piano.
up on like the math. I was like,
Oh,
I did with the logic.
the math when it kicked me out of school.
You know, the concert. And I didn't know. I was always just act like I was
I actually played. That sounds actually interesting. You think you were playing?
like, I was so bad at it. Like, no matter how much I practice, I could never do it.
All right. So there's something else that comes out of this. Sometimes you can simplify things a little bit. You should try to do that whenever possible. The absolute value of tan of e to the x. If it's always positive, then you can remove the absolute value, right? If whatever's inside an absolute value is always positive, then you don't need the absolute value. So you should check momentarily, is tan e to the x always positive? Well, I know that e to the x is always positive, right? So when I put it in tan, is it possible to get negative values? Yeah. You can put positive things in the tan and get negative values. So this could be negative, so I do not want to take away the absolute value. It needs to be there. And over here, this, I'm just going to take this little piece here for a second. It probably works. So you have tan squared. The square is going on the tan function, right? Tan squared, and e to the x is inside there, right? And it's minus 1. Is this, without the radical, is that an identity?
Yeah.
Is tan squared minus 1 an identity?
Minus tan squared minus. Is that equal to is that a Pythagoras?
It's a Pythagorean. It could be a Pythagorean identity. So the fundamental Pythagorean identity is sine squared x plus cos squared x is 1. If you divide this all by sine squared, you will get 1 plus cotan squared x equals secant, I can't write, equals cosecant squared x. If you divide the whole thing by cos squared, sine squared on cos squared is tan squared. Cos squared on cos squared is 1, and 1 on cos squared is secant squared. That is how I remember the three Pythagoreans. I remember the first one, it's straightforward enough, and then I just divide by whatever I want to get the other two if I need them. Okay? So, no. Tan squared minus 1 is not an identity. Tan squared plus 1 is. Right? It's easy to make a mistake if you don't remember them properly. So there's no simplifying this into a secant squared EVX. That's not going to happen. Okay? So it's also stuck how it is. So there's nothing to do.
So you want us, like on a test, you would want us to either.
I would be
change it-
happy with this.
You'd be happy.
At the
with
stage you're at right now, looking at your blurry eyes, I would be happy with this. Yeah, that would be good right there.
Blurry
That you
eyes.
used the formula correctly for the inverse trig, and you made it through your chain rules. Pow, that's good.
Just, okay. Can we try one with numbers in it?
I don't think there are any.
No?
No.
So the
Doesn't look like
exam is
it.
gonna have one without numbers?
I mean, here's one with numbers. You ready? You ready?
I'm ready.
Here's one with a couple numbers in it. Tan inverse, well actually it's 1 over tan inverse.
What number is it?
28. I hope I did this.
You didn't, unfortunately.
Great. 28. Do something to strive for. 1 over. Tan inverse of x squared plus 4. So there. There's two numbers, so 2 and a 4. I can't count. Well, I guess it was a 1. That 1. I can't count that one. That doesn't really mean 1.
Wait, don't you have to do the
Quotient rule. That's one possibility. Or you could take this and encapsulate it in brackets and write -1 and do a power rule. It's your choice. You want to do a quotient rule or a power rule?
Both
I mean, if we do the
sounds-
power rule, we're gonna have to move it back down to the final answer, right?
It's quite possible, yeah.
Can we just leave it like that?
Yeah, just do it.
Do like, okay, quotient it is. That's what you want. df dx. Bottom. So that stays the same. Tan inverse. And remember that this symbol here means inverse function. It does not mean reciprocal, right? Tan reciprocal is already cotan. That's already a whole other function, right? This is tan inverse, some other thing altogether. It does not mean reciprocal, like I can move this up. If I move this up here, this becomes regular tan. It does not. That's not what we're saying, right? It does not do that. It's not an exponent, is what I'm trying to say. It's not an exponent. It's a symbol that means inverse function. Tan inverse of x squared plus 4 times what? The derivative of?
1,
Which is?
0.
Good.
So doesn't it just cancel?
So that's gone. Minus.
Wait, what'd you do?
Bottom
0.
times the derivative of the top is the first part of quotient rule. Bottom times derivative of top.
Okay.
Anytime it's a constant over something, you should always expect this first one to go to 0, right? Minus what? Top, which is just 1, so I'm not going to write it, times the derivative of the bottom. So now we've got to do negative d dx of the bottom. Tan inverse x squared plus 4. We can accomplish that, and we also have to square the tan inverse below. Be careful, make sure you put the square on the outside of the whole thing. Please don't write -2 here. That's not what we want to say. Okay? I know normally the trig functions have the exponent attached to the title and not written on the outside.